Hello, today we are going to take a look at polynomial and rational inequalities. These look like this first problem where we have this polynomial inequality of x squared plus 5x minus 6 being greater than or equal to 0. Our steps with our polynomial and our rational inequalities will look very similar, but we will look at some of the differences later. Our first step for any of these is to factor our polynomial or our rational expression. So in this case, we will factor this into x plus 6 times x minus 1 is greater than or equal to 0. After we have factored, then we are going to write a number line. Okay, so we have our number line, and we are going to label it with an x or whatever variable we are using for this problem. On the number line, we are going to plot the zeros of our factors. So we take x plus 6, set that equal to 0, x minus 1, set that equal to 0. And then we end up with our zeros being x equals negative 6 and x equals 1. It is important to properly label this sign chart, which is what this is called, and the number line that's at the top to make sure that all of our steps are clear and we are sure what each number means in the context of this problem. So once we have these zeros in, we are going to write our factors on the left side. So right under our x, we will write these factors, our x plus 6 and our x minus 1. We are also going to have a row for f of x, which is what we are using as a stand-in for the entire expression. You also have the option of writing in that x squared plus 5x minus 6. I just tend to like the f of x because it is less characters to write. So then from here, we are going to plot the zeros again, but later in the chart. So if you take a look at substituting these values of x, and part of why it's labeled is because we know that, hey, this negative 6 and any of these other values on this number line are going to be substituted in for x. We take this negative 6, substitute it in to each of these expressions. But really, we only need to look at it with the one factor, this x plus 6. When x is equal to negative 6, x plus 6 is equal to 0. We are going to do the same thing when x equals 1. When x equals 1, this row for this factor x minus 1 is going to have a 0 because when x is equal to 1, x minus 1 is equal to 0. Everything in this part of the table of this sign chart is what the value of each of the factors is going to be. And then what we're going to do is substitute in more points. What we'll do is take a value that's less than negative 6. It's a number line, so pick whatever your favorite number is, less than negative 6. So let's use negative 10 for now. Substitute that into each factor. Negative 10, so I'll just write it here because that's what I'm using to help for a little visual, remind us here. Negative 10 plus 6 is going to be a negative 4. But what we're going to do is only put the sign. That's all that we will need to answer our problem and justify our answer here. So negative 10 plus 6 is negative. Negative 10 minus 1 is also negative. We're going to do that for each row. You can use the same value because it's going to be on the same interval for each of the factors, for each row here, how it will look in the table. So let's pick a number that's between negative 6 and negative 1. Anytime that we have something like this, I like to use 0 just because it makes life a little smoother for completing these rows. So 0 plus 6 is positive. Again, we only need to write the sign. 0 minus 1 is negative, and we write a negative sign there. We do something again on this interval. Let's say 2, because 2 is greater than 1. 2 plus 6 is positive. 2 minus 1 is also positive. Then we'll complete our f of x row. And I know this looks like a lot of steps, but I'm just writing out every little one here for our first time doing this. As you get more practice, it will feel smoother and you will be better practiced doing these. So since we are multiplying these factors together, if you take a look up here at our original expression, anytime that we multiply these values together, we have to think about what the sign is going to be. So our x squared plus 5x minus 6 down here, or if you wrote it as f of x, it's going to work out the same way. That is going to be a product of those two factors. So a negative multiplied by a negative is going to be a positive. A 0, when x is equal to negative 6, x plus 6 is equal to 0. It does not matter that x minus 1 is equal to negative 7 because negative 7 multiplied by 0 is 0. So we can actually just bring all of our zeros down, and you'll see in later problems I will do that pretty early on in the problems. Then let's figure out what's going on this interval between negative 6 and 1. A positive multiplied by a negative will give us a negative. Positive multiplied by a positive, that product is also positive. Now, I know I need to scroll down a little more. We need to answer in interval notation. This is our entire justification. We just need to finish up the problem. So we're looking for when this expression is greater than or equal to 0. So we just have to think about what types of numbers are greater than or equal to 0, and we see our positive numbers or 0. So it's on this interval, but then we're looking up here because it's in terms of x, so we need to look at what type of numbers are represented on those intervals on the number line. We're going to do this in interval notation. So over here it goes between negative infinity and negative 6. We'll use the square brackets because it's greater than or equal to 0. So at x equals negative 6, the expression is equal to 0, so it counts and is included. Same thing over here at 1. We go from 1 to infinity. Let's take a look at a rational one after you are going to do this one for practice. So our rational inequality, we're going to start out the same way. We do any sort of factoring that we're going to do first, which in this case, we don't have to do any factoring. We're going to do number 9 here. And we're still going to set out our number line, label it with x, and write out our zeros. So this whole f of x, this left side, is going to be equal to 0. Well, the 0 of x plus 5 is in the denominator is when x is equal to negative 5. And then the 0 of the numerator is going to be equal to positive 5. we're also going to take our factors. We'll call them factors even though one's the numerator, one's the denominator, and write them down the left side. So we have x minus 5 and x plus 5, and we have that row at the end for f of x, or you can write the entire expression out, whichever works best for you. Now let's find our zeros. So when x is equal to negative 5 over here, x plus 5 is equal to 0. When x is equal to 5, x minus 5 is equal to 0. So that's why we put this 0 in this row. Then let's substitute some values in, just like we did with our polynomial one. A number that's less than negative 5, so we'll say negative 10. Negative 10 minus 5 is negative. Negative 10 plus 5 is also negative. A number between negative 5 and 5, I'll use 0. I always like using 0. 0 minus 5 is negative. 0 plus 5 is positive. Then a number greater than 5, so 6. 6 minus 5 is positive. 6 plus 5 is still positive. Now, all of this has looked identical to a polynomial inequality. So if this had been x minus 5 multiplied by x plus 5, all of this work would be exactly the same. And the next step would be the same as well. So when we're trying to find our f of x row, so negative divided by a negative over here, negative divided by a negative is going to be a positive. Negative divided by a positive or positive divided by a negative, it doesn't matter which order you write the rows in, is going to be a negative. Positive divided by a positive is going to be positive. This step is going to be the same for polynomial and rational inequalities. The difference is when we bring our zeros down. When x is equal to 5, our numerator of the x plus 5 is going to be equal to 0. 0 divided by any number that's not 0 is going to be 0. Okay, cool. Looks exactly the same. When x is equal to negative 5, x plus 5 is in the denominator, and we can't divide by 0. So that's going to be undefined, our f of x expression. So we'll write a little UND for undefined. This is our difference between our polynomial and our rational inequalities, is how we deal with that f of x row when we have a 0 in the denominator. Now we're looking for when this is less than or equal to 0. So that tells us we're going to have negative numbers. So we're going to be looking at how a highlighter does not work on this background. Still writing in the highlighter. So we're looking for this interval. We do not include that negative 5, so we'll use parentheses there. And it's this interval where x is between negative 5 and 5, but it does include number 5. Now, next you are going to try out number 10 on your own, but thank you for watching, and see you in class.